On July 1st, 2025, a robotic sky survey system in Chile flagged a single moving point of light that didn't belong to anything in our solar system. Within days, astronomers around the world confirmed it. This was only the third object in the entire recorded history of astronomy ever detected coming from beyond our solar system, a visitor born around another star in another part of the galaxy that had been drifting through interstellar space for longer than most of us can properly imagine. Almost a year later, in June 2026, a team of scientists gave that number an actual figure, published in the journal Nature. This object may be up to 12 billion years old. Our sun is roughly 4.5 billion years old. Our entire solar system is roughly the same age. This visitor could be nearly 3 times older than both, a fragment of the galaxy that existed long before our sun ever ignited, passing directly through our neighborhood and then leaving again forever. If you want the real story, verified against the actual published research, rather than exaggerated for a headline, stick around because what scientists have confirmed about this object doesn't need any exaggeration at all. The object is called 3I Atlas, and the name itself tells you exactly what it is. The 3I means it's the third confirmed interstellar object ever detected, following 2 previous visitors. 1I, or Oumuamua, discovered in 2017, and 2I, Borisov, discovered in 2019. Atlas refers to the asteroid Terrestrial Impact Last Alert System, the network of automated telescopes in Chile and elsewhere that first caught it moving across the sky as part of a survey originally designed to spot potentially hazardous asteroids before they could threaten Earth. Once astronomers plotted its trajectory, the math was unambiguous. Objects that belong to our solar system orbit the sun in a closed loop, bound by the sun's gravity, the same way Earth and every planet does, tracing the same repeating ellipse over and over for billions of years. 3I Atlas wasn't doing that. Its path was hyperbolic, moving too fast and on too steep a trajectory to ever be captured, into orbit around the sun, with an eccentricity so extreme that it immediately ruled out any possibility of a native, long-period solar system origin. It came from outside, it swung through, and it's now leaving again, permanently never to return. To understand how rare that actually is, it helps to know just how few of these objects we've ever found. In the entire history of telescopic astronomy, spanning centuries of watching the sky, humanity has confirmed exactly 3 objects that definitively originated outside our solar system. The first, Oumuamua, was strange enough on its own. An elongated object that didn't behave quite like a typical comet or asteroid, tumbling in a way that made its exact shape difficult to pin down and showing no obvious cometary tail, despite its unusual acceleration as it left the solar system, which led to years of scientific debate and, briefly, some highly publicized speculation from a Harvard researcher that it might be artificial in origin, a theory that NASA and the overwhelming majority of the scientific community did not support. The second, Borisov, behaved much more like a familiar comet, complete with a visible dust tail and outgassing patterns similar to solar system comets, giving astronomers a clearer, if brief, look at cometary material from another star system. Then came 3I Atlas, and it turned out to be the most useful of the 3 by a wide margin, mainly because of one simple factor. It was bright. Unlike its 2 predecessors, 3I Atlas was luminous enough at the right time for major observatories around the world to actually gather detailed spectroscopic data, breaking its light apart into individual wavelengths to determine what it's actually made of, rather than just tracking a dim point moving across the sky for a few brief weeks before it faded from view entirely. That difference mattered enormously because it turned 3I Atlas from a curiosity into a genuine scientific opportunity. As astrophysicist Rosemary Dorsey of the University of Helsinki, one of the researchers who studied the comet, put it, this object gave scientists a real chance to probe the composition of another planetary system entirely, one that formed long before our own sun and solar system ever existed. That's not a metaphor. The material boiling off this comet as it passed near the sun is physically, chemically, literally from somewhere else, formed under conditions around a different star, sometime in the galaxy's distant past. 3I Atlas made its closest approach to the sun on October 29, 2025, passing at a distance of about 1.4 astronomical units, meaning roughly 1.4 times the distance between Earth and the sun, close enough to be meaningfully heated, but never posing any collision risk to Earth or any other planet. As it neared the sun, solar heating caused it to release gas and dust, exactly the way any comet does. Its surface ices sublimating directly from solid to gas and forming the surrounding cloud of material called a coma that made it visible and studyable in the first place. That outgassing gave astronomers the rare window they needed, Using instruments including the James Webb Space Telescope's spectrograph, the Hubble Space Telescope, and ground-based observatories like the European Southern Observatory's Very Large Telescope and the Gemini South Telescope in Chile, researchers were able to examine the specific molecules boiling off the comet, and more importantly, the specific isotopes contained within them, the slightly different atomic versions of elements like carbon and hydrogen that get locked into ice and dust, based on the exact conditions under which they originally formed. That's where the age estimate actually comes from, and it's worth understanding briefly why isotopes are the key to this puzzle rather than something simpler like the comet's speed or trajectory. Tracing an interstellar object's path backward through the galaxy doesn't reliably tell you when it formed, only roughly where it's been traveling from, since objects can drift through interstellar space for a very long time before we ever encounter them, and the galaxy itself has been rotating and reshuffling stellar neighborhoods the entire time, meaning a straight-line backtrack of its trajectory tells you almost nothing certain about which star it originally came from or how long ago that star existed. What actually holds a much clearer signature of age is the ratio between different isotopes of the same element trapped inside the comet's ice, because those ratios are influenced by the specific chemical environment and stellar generation the material originally formed in, effectively acting as a kind of chemical fingerprint baked into the ice long before our own sun existed. Using the James Webb Space Telescope's near-infrared spectrograph, a team led by Martin Cordner at NASA's Goddard Space Flight Center measured the ratio of carbon-13 to carbon-12 in the gases boiling off 3I Atlas. And separately, researchers using the European Southern Observatory's Very Large Telescope examined isotopic ratios in the cyanide molecules present in its gas cloud, checking one measurement technique against an entirely independent one. Both lines of evidence pointed toward an old carbon-poor origin, consistent with formation in what astronomers call the galaxy's thick disk, an older, more slowly rotating population of stars, distinct from the younger, flatter disk our own sun belongs to. Based on that isotopic evidence, published in Nature in June 2026, Cordner's team estimated 3I Atlas could be as old as 12 billion years. A separate analysis, using the comet's unusually steep, fast trajectory, arrived at a somewhat more conservative, but still staggering estimate, somewhere between 3 and 11 billion years old. Either way, the conclusion holds. This object very likely predates our own solar system by a wide margin, and quite possibly by billions of years, making it, by a significant distance, the oldest object humanity has ever directly observed and measured up close. It's worth sitting with what that actually means in practical terms. Our sun formed roughly 4.5 billion years ago out of a collapsing cloud of gas and dust in what was, at the time, an entirely ordinary corner of the galaxy. Every planet, every moon, every asteroid, everything in our solar system, including us, is built from material that came together after that point, recycled from the same original cloud. 3I Atlas, if these estimates hold up, was already an old, formed object, drifting somewhere out in the galaxy's thick disk, before our sun had even ignited as a star, meaning it has existed through the entire history of our solar system's formation. The rise and extinction of the dinosaurs, the entire span of human history, and untold billions of years before any of that even began. It has spent the overwhelming majority of the galaxy's entire history simply traveling, unattached to any star system, through the vast, empty distances between them until a chance trajectory brought it, briefly close enough to our own sun for a network of telescopes on a small rocky planet to notice it passing by. This wasn't the first time an object like this generated intense public attention, and it's worth addressing that directly, since a fair amount of noise around 3I Atlas involved speculation that had nothing to do with the actual published science. Shortly after its discovery, a prominent researcher publicly floated the idea that the object might be artificial, potentially even an alien spacecraft, based on some of its unusual characteristics, generating enormous media coverage and online discussion. NASA and the broader scientific community reviewing the actual data did not support that interpretation. Every subsequent observation, the spectroscopy, the outgassing behavior, the isotopic composition, has been consistent with a natural comet, behaving the way comets behave when they're heated by a nearby star, releasing gas and dust in predictable patterns, tied to solar heating rather than anything suggesting controlled or artificial behavior, propulsion, or deliberate trajectory changes. The genuinely remarkable part of this story was never that it might be something built by an intelligence. It's that it's a real natural fragment of the galaxy's ancient past, and we happen to have the instruments ready at exactly the right moment to actually study it, a fact that turned out to be far more scientifically valuable than any speculative alternative explanation. Here's where it's important to be precise about where 3I Atlas actually is right now, rather than where headlines from its discovery period might suggest. Having already passed its closest approach to the Sun in late October 2025, the comet is now moving away from the inner solar system, back out into interstellar space at a velocity of more than 60 kilometers per second relative to the Sun, fast enough that nothing in our solar system has any chance of gravitationally capturing it. No planet, no moon, nothing with enough mass to alter its escape. It passed through our cosmic neighborhood once, briefly, on a single unrepeatable pass, and it will never come back. Within the next few years, it will cross back beyond the orbit of the outer planets and continue on its way, indifferent to anything happening on the small rocky planet, whose telescopes happened to catch a brief glimpse of it during the few months it was close and bright enough to study. None of this diminishes how significant the discovery actually is. Quite the opposite. Researchers studying a 3I atlas have been careful to point out that this is very likely just the beginning of an entirely new field of study. For most of astronomical history, examining material from other star systems required sending spacecraft to distant bodies within our own solar system, or analyzing meteorites that happened to fall to Earth. An extraordinarily indirect and limited way of studying the wider galaxy, since meteorites tell us almost nothing definitive about which star system they originally came from. Interstellar objects like 3I Atlas offer something categorically different. Genuine physical samples of material formed around other stars, arriving on their own, requiring no spacecraft, no decades-long mission, no round trip, no billions of dollars in mission costs. We simply need the instruments ready and pointed in the right direction when they happen to pass through, which is precisely what made the difference between 3I Atlas and its two predecessors. That's precisely why the timing of this discovery matters so much for what comes next. The Vera C. Rubin Observatory in Chile, which only recently began full operations, is specifically designed to conduct repeated, wide-field surveys of the entire visible sky on a nightly basis, exactly the kind of systematic search most likely to catch the next interstellar visitor early, potentially while it's still faint and far away, giving astronomers far more lead time than they had with any of the three objects confirmed so far, all of which were caught only after they were already relatively close to the Sun. Martin Cordner, the lead researcher behind the age estimate, described this moment as just the beginning of an exciting new field, one where each subsequent interstellar object promises to teach us more about the wider galaxy and the vast population of stars and planetary systems scattered across it, most of which we have never had any direct way of studying at all, short of waiting for a rare, unrepeatable visit like this one. 3 confirmed visitors in less than a decade, after literally centuries of astronomy finding 0, tells you something concrete about how survey technology is finally catching up to how genuinely common these objects likely are drifting through the galaxy at any given moment. Most of them pass by too far away, or too faint, or in paths that never bring them anywhere close enough to notice, unnoticed fragments of other star systems slipping through our cosmic neighborhood without a single telescope ever registering them. 3I Atlas happened to be bright enough, close enough, and detected early enough for the world's best instruments to actually study it in detail. And what they found was a fragment of the galaxy that may have already been ancient before the Sun itself existed, passing silently through our solar system and continuing on a journey that will likely outlast every star currently visible in Earth's night sky, drifting onward long after. Every telescope that ever observed it has been dismantled and forgotten. If you want to know the moment the next interstellar visitor gets confirmed, subscribe and turn on notifications, because with new survey telescopes now fully operational, astronomers expect the next one might not take another 6 years to find.